That you have to end 10 minutes early? I assume always. At U of T, they do it, it's stranger. Every course starts 10 minutes late. So if they say there's a talk at 3 o'clock, you get there at 3 o'clock, there's nobody there. People come at 3:10, and then they go until 4. Different. Yourself. Yes. Yeah. 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 In fact, the usual guy who talks to me said you're not allowed to use a stack. And I thought, oh, panic. It's impossible to do it without a stack. It's fundamentally a stack problem. And so yeah, you just got to write your own stack. Yeah, so your problem is all supposed to be linked lists, right? So you just build a linked list stack and you're ready to go then, right? Um, yeah, so it can be a singly linked list. So somebody else was asking this question, right? So see if it's right. So this is our guy. Can we add somebody to the front in constant time? Yeah. Can we move somebody from the front in constant time? Can we add somebody to the back in constant time? Can we remove the last guy in constant time? No. So remove last is the hard one, right? So if you're wanting to do a queue, how do you do a queue? If we're doing an array, but here for a linked list, okay, what do you have to do with a queue? You have to remove from one end and add to the other end, right? Well, do we want to remove from here? No, right? So we remove from here. And then how do we add? Well, you add over here, right? Yeah? You're doing which? Yeah, removing the last is hard because then you got to find the second last, right? Then you need double pointers. But if you're right, so I made this one place. There's this thing that says, right here we add, remove, front, back. How do you spell back? Right? The only one that's hard is this one, right? So if you're doing a queue, you do this. And if you're doing a stack, you do this. Right? For stack, you don't need the last pointer. You just do this.